And it's really nice. It's always lovely to welcome alum back into the building, or even virtually. So thanks so much for agreeing to do this talk. She's doing some really interesting work in Dakar. She's one of only, I think, 300 registered architects in Dakar at the moment. So she's leading the line there. And sort of using compressed earth bricks, which she's going to talk about, and also other materials. There is one of these bricks on show at the moment in London at the Royal Academy summer show, or summer autumn show. So please go and have a look at it. But anyway, Nzinga, I'll let you start before this stops working. So thanks again for agreeing to talk.
Thank you, Will. Thank you so much for having me. It's quite an honor to have the opportunity to be back, even if it's only virtually, at my university. And yes, I just feel very privileged to be giving, especially the lecture of technical studies. So hi, everybody. I wish I was there in person. I guess it would have saved us maybe 20 minutes more. But I'm glad that everything is working now. What I want to do today is to talk to you a little bit about the work that I've been doing here in Senegal in the last 4 years. It's been 4 years since I left the UK. I left London. It's been quite an adventure that has sort of led me to specialize in bioclimatic construction and architecture, and particularly using local materials here. So I'll tell you a bit more about it. And I would really, really love to hear more of your questions afterwards. So here we go. So just a little bit on my background. I studied at the University of Pretoria in South Africa. That's where I did my undergrad. There's a picture of the School of Architecture, and one of the projects that I did in undergrad, where I always sort of had a desire to be able to adapt briefs to the local context. So in this particular case, we had to do a modular unit that could fit in a container. And my context in the case of South Africa was an informal settlement in the outskirts of Pretoria. So then, yes, I did my after graduating, I worked for 2.5 years in Johannesburg before going to London. You know, Lindsay, that is in the room, will probably recognize my DS18 thesis project. During that year, we were our main sort of focus was the Anthropocene, and particularly the effect on the environment that will brought in, or that could be brought in by the fracking industry in the United Kingdom. So my project, my thesis project, was in a quarry in Dorset, in a protected area that was where they were actually fracking licenses. So I'm sharing this project as well because I feel that then there was an interest in geology and obviously understanding the impact that extractive industries have on the environment, and not just, you know, in sort of human years, but in sort of geologic years as well. So that was a very seminal piece of work and way of thinking that I learned with this thesis project. After graduating, I went on to work at AJ Associates for 3 years. It was always my dream to be able to work for Sir David ever since I met him back in South Africa. I started working on projects, let's say fairly commercial projects in London. The top one is the headquarters of Goldman Sachs, the auditorium. Below is a project on just above Green Park, Berkeley Street. And then to the right is my final project at AJ Associates, which also helped prepare my transition to Dakar. And those were the offices for the IFC, which is a branch of the World Bank. and it was designed to be a bioclimatic project using raw earth as a material. And it's really through that project that my transition to Senegal was able to happen. And here are some of the bricks of that said project, the IFC project. So I left London in 2017, so I've been in Dakar now for 4 years. I will tell you more about then the context in which I'm operating and what Dakar, Senegal is a bit like in terms of architecture, and particularly urban architecture as well. So for just to position ourselves within the African continent, so I mean Senegal, but particularly Dakar, is the most western tip of the whole African continent. That is the shape of the country. We was sort of divided during colonial times between the French and the English. So the little bit, the mouth that you see is actually the Gambia. So we have a country practically split into half. And I've chosen this particular image, which is about, I believe, 4 months old, maybe. And this was taken by an astronaut, a French astronaut called Thomas Fouquet, who is orbiting the Earth with a space station. So he was just above Dakar. And he took this picture, which was a very sweet moment to be able to obviously, see our beloved peninsula from the sky. But then there's something very very sort of worrying as well about this picture. I think the number one thing is really being made aware or reminded of the fragility of Dakar, because on the neck, in a way, you can see that there are some, or maybe it's not very clear, but you have a big lake, and there's always sort of this idea that we could be cut off from the mainland. And then on top of this, you can see that most of the peninsula and the extension going outwards are all gray. And this is showing how predominant concrete is as a construction material, and the sort of overall landscape is becoming more and more gray and less green. And just for sort of anecdotal here, Dakar, this peninsula was called the peninsula of the bird, which is of the Green Cape, and it was named like this in the I believe 16th century because it was so green. I guess this was given by probably European explorers that found it so green that they named it the Green Cape. And here we are now. We've come a very long way since those days. This is what the capital looks like. I think from this picture you can probably see where I live. This is taken from one of the big statues. This was a couple of years ago because this area was still being developed. But you can sort of, this gives you a bit of an idea of Dakar's urban landscape. Very far. This was taken on a sandy day because, given our proximity to the desert, we get a lot of sand. Some maybe not sandstorms, but the air could just be filled with sand particles. So this was one of those days. At the back is the ocean. It's not very clear, but just in terms of the built environment, you can see the predominance of concrete. It doesn't rain a lot here. Therefore, most of the construction opted for flat roofs, as you can see, and this area, for the last 5 years, has even expanded and has densified further than what you can see. And this is something that has happened only in the last, let's say, 20 years or so. It's all new constructions that you see on this picture. This is a bit more of a close-up picture of the site of the last project that I will show you. So if you can just bear that in mind to sort of see with the context within which we are implementing our buildings And I guess it will make a lot more sense, why we saw an opportunity to do what is it that we do. So this is again in Dakar towards the north. It's a place that used to be a village and has been urbanizing for the last 20 years. So you can see, some built, some construction, some under construction still, and that's where we have done our main project, I guess these days, which is a multi-story family home. This image, I guess, speaks to me a lot more of the pressure that is on the city. I had done previously a study on housing in Dakar, a research project. I'm not, I'm not talking so much about it, but with these investigations, what we found out is that even when a building has been built up to a certain level of story, after a few years, what you see is the building being extended. I guess the picture on the left makes it more like a bit more obvious where the building had stopped and then the extension that happened afterwards. It's sort of the same with the images on the right. These are vertical extensions that have been placed on buildings because of the geography of Dakar. In a way, there's very limited ways to expand. So the expansion now is becoming a lot more vertical. It's creating a density that sometimes is a bit suffocating because it increases the urban heat island effect, limits obviously spaces for ventilation, less and less greenery, and most buildings here are very uncomfortable, especially hot unless you have AC. So there's a general dependence on using air conditioning in order to have thermal comfort in the buildings, which given the global, I guess, challenges that we face with global warming, but also the scarcity of resources and our dependence, especially on fossil fuels, because the electricity here in Senegal is still mostly, it mostly comes from fossil energies. I already, like I said, through my education, especially at Westminster, became very sensitive to these questions. And this is done, so I'm talking about the capital, but then if you look at Senegal and we sort of look back a little bit at traditional architecture and vernacular architecture is really the departure point for us, not just in Senegal, but I guess you could talk about it in many places, because whenever we study the typologies, we study the morphology, we study the material usage, we always see buildings that were made to fit their context, and you made while using the materials that are sort of locally available, and using a sort of and making putting them in such a way that you will get you'll be protected from the elements. So if it's in a very rainy area, like in this case, these are houses from the south of Senegal, so it's the part that is just below the Gambia. It rains a bit more there than in Dakar, which is in the north, and they have these houses called impluvium houses, and you can see there's sort of these inverted roofs into this courtyard. And we last time when I went, I saw a couple of these drawings that were done by some architects showing the different typologies of ththese houses. And they also these sort of mini fortresses in which a family live. That's why they usually only have one entrance. And this is what they look like. This is a house from the outside. So it's earthen walls. The walls are made with earth. The roofs are thatch roofs. They sort of have this double slope, so one external and the internal one goes into an inverted cone, which is a light well, but then the rainwater is also collected and then drained out with a drainage. And you can see a little bit the type of material quality of these earthen walls, and I don't know if you can see, but you have all these various stripes and layers, which maybe some of you know about a bit, and you've seen in rammed earth construction. In this case, it's not rammed earth construction. It's it's cob construction that is being used, and this is one of the sites that I visited again in Casamance, and all of this is the same site. So what you have is the extraction point of the soil, literally in the backyard. The soil is then wet with just a bit of water, and by hand, people build the walls and then compact it with their hands. So unlike a rammed earth construction in which you need to have a shuttering and then compact the earth with a tool, this is all done by hand. And and the same thing with the wood for the lintels, for the roof structure, is done cutting trees again in the backyard. So none of this material is transported. Maybe outside of the thatching, which I think comes sometimes as well from the rice field. All of it is just done using what is literally found in the backyard. And then what I also found out with the different layers is that in one weekend, everybody comes together to help whoever needs a house to be built. In this case, it was a house and bar that was being built. And I saw the owner, he literally just drew it with a line, the plan on the ground. And then he got a couple of these friends to help him build it. And they do one layer per weekend. So they work Saturday and Sunday when everybody is available. One layer is being built. They leave it 1 week to dry until the next weekend. And then they come back and they do the next layer. So the building time on average of a ground floor house takes about 6 weekends, really. And I must say I was quite amazed at the simplicity, I guess, of these construction techniques, because the ones that we use in the city are a little bit more complicated. So this was a very nice learning experience for me to see Earth being used in such a simple yet efficient way. This is another example of houses that are made using earth, but this time in the north, so a little bit closer to the border with Mauritania. And you can see in this case that a lot of, I mean, we read the sort of climate in which these are being built, because you don't see the big overhangs. I mean, other than on this image here, where it was there was just a little bit of a sort of roof structure that was put for shading. Really, these structures aren't really done to prevent any type of rain. The construction technique here, I don't know if you can read on these images, that these like stripes of bricks, they are adobe bricks, and in this case, the bricks are the earth is put in a mold, just let's say a simple wooden or metallic mold, to make bricks, and then it's sun dried. So this is also something that is very manual, doesn't require any type of machinery, and then afterwards the earth are rendered with the same earth material, and you can see that there's a few what do you call it? There are a few gutters to sort of drain the little bit of rainwater whenever it actually rains. And then the last piece of, let's say, vernacular architecture that I wanted to share is this one, which is in the border of Senegal and the Gambia. So that will be the northern border of the Gambia. And these are megaliths that date back, I think, to the 11th or 13th century. I mean, there are quite a few that span across time. And these, there's a big enigma, and I guess, you know, a little bit like with Stonehenge in the UK, about what the purpose of these megaliths were. And some sort of speculate that they were funeral homes, that they were tombs. Some associated with a bit more mystical practices. But I wanted to share this because these megaliths are made out of laterite. of a laterite rock. And the laterite, I'll show you later, is the rock that is then crushed in order for us to make the bricks. But in its natural state, it's very solid. It can be cut into these pillars, as you can see, and it's just very labor extensive, but it's still a very sort of solid material. And that has obviously that stood the test of time. So getting more a little bit in the materiality of the earth that we use here. This is the laterite that we find within the, let's say, 60 kilometers of Dakar. This is what it looks like. This is laterite that has been sort of excavated from the ground. So when you excavate it, it looks like this. It's these blocks that have sometimes more solid particles, a bit of sand, obviously some like clay particles as well. It's a sort of mix of different type of silt, sands, and clay. Then this is just to show you the variety of clays that we have here in, I think honestly, all of these were found within, I would say, 100 kilometers of Dakar. Because on the same site, sometimes you could have the first 2 meters where you have, let's say, a white type of clay, like the one that we have here. Oh, no, sorry, usually it's the black one first, and then you dig a little bit deeper, you'll find the white one. We find the laterite mostly on the inland, and then there's this sort of gray clay that we find towards the coastal area, which is also very favored by ceramicists that make potteries and things of the sort. So this is just to show the diversity of the type of clays that can be found or in the vicinity of Dakar. But the main one that we use still being the laterite one. And this is just to show a little bit the characteristic, I guess, of this is on the ground on which we find laterite. You obviously see that it has a lot of elasticity because when it dries up, you sort of have this construction that happen. So that's whenever we go on the site, usually the first tell sign that we have an earth that has a lot of like a high clay content. And this is just a sort of table to kind of show how earth changes depending on how much water you put in it and how compacted it is. So the same, and I guess if we get more in material science, depending as well on the type of earth construction technique you use, you need to have a very sort of a particular humidity level and compaction level as well with the earth. And this is the factory, which again is about 60 kilometers away from Dakar, where most of the infamous bricks, Dakar bricks, are being made. This is they are made using crushing laterite, adding a little bit of sand, stabilizing it with. So far, we use about maximum 8% cement to stabilize them, and then they are put into this mechanical press. I mean, in this case, it's manual, but it's a press that is engineered to sort of give maximal compaction, and that's what produces the bricks. So you see a little bit more of a close-up of the process of how it's made. So below is the mixing happening. You can see different sands being sort of added to it, the press, and then the bricks that are being produced. On the fact that we add of this particular technique, add cement to stabilize it, and why we use it is if you go back and you remember what the image of the sort of architecture in Dakar looks like, where you have these straight walls, flat roofs, etc. All the facades, especially the wall facades, are not protected from the water elements. So that means that if we don't protect the walls with an overhang, like it's done in the south of the country, after a few rainy seasons, the walls will start to erode. So using cement, but it could also be lime, just allows us to stabilize the bricks in order to leave them exposed, really. So there are so many different techniques. I've already named a few. This is probably the technique that gives us the most constraints, technically speaking. That's maybe the less also sustainable, just given the sort of even though they're not sort of fire, these bricks, and they're all completely sun dried, but they have to cure for 28 days just because of the little bit of cement that we have. So this is sort of a technique that works, I guess, for the context of the capital. This is a sort of now industrial material, if you can say it. It's being produced in a factory, and when, and I'll tell you more as well about the manufacturer of these bricks, has told me that this was the easier way to make people accept earth as a solid material. These are some prototypes of the bricks that are made as well, and they're U-shaped because they can be used for lintels, so sort of above, and seals as well. We often use it in contexts in which we don't want to expose any of the concrete that is used for structural purposes. And this was just to show again the diversity of colors that we can have. And this is just with the same laterite. The bricks are made, but then we tested different types of sand. If you remember on the previous pictures, we had like a white type of sand, and then we had a yellow one. So we're just playing with different admixtures. We can get sort of these natural palette of colors. And below is sort of a test that we've done for renders on walls, again, using various mixes, but this is without any sort of colorant, but just using all the local clays that we can find. And this is just an illustration of the adobe technique that is used traditionally in the north. So this relies on just this little mold that you see here. You take the earth, you wet it a bit, you put it in, and then you let it to dry. Oh yes, sorry, I forgot to say as well, with compressed earth blocks, they can have a really high compressive strength, sometimes higher than adobe, which make them really good to have load-bearing walls, which I'll get to when I show you the project. But some of the adobe projects, depending on the type of clay that we find, can also be load-bearing, but generally we would have to be sort of limited, let's say, to just 1 story or 2 maximum, if you were to use adobe as a building construction technique. And lastly, on the materiality point, I just want to introduce you to this other material that is very important for us in this particular context. It's called Tifa. It's a type of water reed which grows in the neck of Dakar, of the peninsula. I was mentioning the fact that there's a lake there, so we have this plant that grows a lot there. And it also grows on the border of the Senegal River, which is the north, on the border of Mauritania. And it looks like this. It's almost like a weed. It's very, very invasive. It's caused a lot of environmental issues because if it grows in a point, let's say, where a river meets the sea, or just like at a point, and it blocks the water flow, it sort of disturbs the ecosystem. So it's at times been a very problematic plant. Also, it grows very, very quickly. But what we've realized, and there's a national program for the promotion of this material is that it's an excellent it's an excellent insulator. It's really excellent in insulating roofs, especially here. Like I showed you the image of the car, people use flat roofs that are not insulated. We know that in this case, the roof is the fit facade, and it's the one that is constantly exposed to the sun. So we found out that by mixing this fiber with clay, with laterite, we could make, because the laterite then has also the elasticity and sort of is almost like a glue. We have, sorry, the clay is actually more like the glue. We have the possibility to create these beam blocks that can be used directly for beam and block slab construction, or we could just make panels that are about 600 by 400 mil. They vary in thickness. We have 60 mil, 100 mil thickness, and this could be used to insulate literally anything. It can be placed on any surface, interior, exterior, etc. And thing as well with this particular fiber is that it doesn't have any cellulose, which means that termites cannot attack it. And it can also be used for thatch roofing, which makes it extremely, extremely durable. Because, like I say, it also comes from the water, so it's a very durable material. This is a picture of our collective. So the story behind Worofila centers around this lovely gentleman with the beautiful smile on the left. He is the owner of the factory that produces the compressed earth blocks. His name is Doudou. He's Senegalese. He studied in France. He went to a school that specializes in training people to give them construction knowledge on how to build with earth. And his only dream after finishing the school was to move back to Senegal to really show people that it was possible to do it. And he studied obviously extensively all the traditional earth techniques. So yes, so we all the three of us on the right are architects that all met around Doudou. And I met Doudou through doing the project, the AJ project, because he's the one as well that is producing the bricks for that project. And you have Nicolas in the middle, who's the French architect who moved to Senegal around the same time as I did. And then Shil, who's an Indian architect who also went to the same school that Doudou went to in Crater, and has built for about 15 years in India, has built in earth in India. And when he moved to Dakar, I think it was just the perfect timing for all of us to meet and exchange knowledge and yeah, build collectively. The first project that we did, so as soon as I arrived, there was a competition that was organized by the Ministry of Environment. They wanted to have a building in a sort of rural town of Senegal, and they wanted it to exclusively be made with earth and this TIFA, because the Ministry of Environment, or let's say particularly one person there, has been a fierce advocate to do a couple of things. I guess it's promote the use of TIFA as a building insulator, but also as a potential source for coal because it's a slow burner. And he's also been advocating for a national program to increase the thermal efficiency of building. And ultimately as well, what he's advocating for is for buildings before they get a planning permission to be able to sort of showcase that they will perform in a passive manner. And for us, this is something that is very key to our philosophy, is that although through my experience with the IFC project, I've learned about bioclimatic construction in how the architecture is made, but also through all the different systems that you can have, like solar panels or ventilation systems, etc. But I think given the context here, and we feel that it's best to advocate for passive systems to make sure that people, without even needing additional sources of energy, will have a thermal comfort in the building that they live in or that they work in. So for this project, we made a proposal that sort of included landscaping and the architecture that is organized around a couple of courtyards, maximizes cross ventilation, and you know, have a specific orientation to prevent direct solar insolation. Sorry. And so yes, these are the principles, all the various core charts that allow for the maximized ventilation in this project. And we were to use an inverted roof again, like with the Impluvium houses, to have be able to collect a minimum of water to come into a landscaped courtyard. And the rest of the buildings were made with earth and Tifa bricks. That was the idea. And then the same agency, Ministry of Environment, had already had a project before we arrived, before all of us sort of arrived to Senegal, let's say in 2016, 2017. This was developed with the School of Architecture, the Crater, which is a school that Doudou of Élémentaire went to. And what they wanted to do is to make an experimental building that is state-funded, that is in this new city that is being built, to showcase what can be done with earth and with Tifa as a building material. So it's meant to be a didactic building in which different techniques are used, and to also be measured to see how it performs thermally speaking. So this is quite an important project here, because it's meant to be a sort of example of what can be done, and to also give us input after being measured for a couple of years to understand how these combination of the two materials perform. So this was the project under construction. You could see that, for instance, on the walls, you have the earth and Tifa bricks. You can see that it's a bit fibrous. And then you also just have the compressed earth blocks and these parts and the sills, and on this wall as well. And what you see on this picture are the earth and Tifa panels that were used, I think, like this to insulate roofs, but on the inside ceilings, and some of the walls, especially the ones that are western facing. And then the other principles as well that we use, which is to have the jellies or moucharabier, to have perforated walls that can favor ventilation. This is one of the rooms in the same project. So this is what it looks like from the outside. You have a couple of different modules that each use a different technique. The one here below on the right is made using Adobe. And I'll show you then a picture on the wall. We played a little bit with Tifa and to see how it could be used on the outside. And in this case as well, it was meant to be a ceiling. And at the very last minute, we thought, let's try and see if we can just cut some woven Tifa panels. This is just literally the harvested Tifa, just woven with some steel wires. So these panels are about, let's say, 1 times 2 meters big, and they usually use in traditional architecture to make palisades. So we just decided to cut it in this 600 by 600 grid and place it on the ceiling structure. And I must say, one thing that is amazing about this particular roof, on top of the materiality that it gives, is the acoustic qualities, because we also realized that Tifa has great acoustic properties, and a sound engineer that visited this building said that it's the perfect acoustic that you can get, let's say, for a studio environment. It's really maximized absorption on the ceiling. So that was our experimentation with the same Tifa panels, where we cut them to see how we could put them on the facade to clad them and protect it from the sun. Because in this case, it was just a very simple galvanized roof structure that was put. The idea was then to add the Tifa on top in order to insulate this galvanized roof. Another project that was done by one of my associates in collaboration with another practice. So this is before we sort of formalized as a practice, when we were still operating very much as a collective. These are stations for the train. There's a new national project to have this train, intra-regional train. So it leaves Dakar, it goes to the airport and it stops on the cities along the way. I think in total it has about 16 stops, 16 or 20 stops. Some are major stations, but the other ones are just these tiny, these tiny sort of train stops. And all of them were made using compressed earth bricks, and done in a way that you have this one singular module and a detached a huge roof that gives an overhang, protects the module, gives it shade, and also creates this quite unique architectural language. And it's almost like a posting, right? Because whenever you have, let's say, a bus stop, you almost want it to read as a sign. And the fact that, it has this very distinct materiality that we don't find a lot of, and this massive roof, it's visible whenever you drive anywhere, you cannot miss it. So there's a bit of an iconic imagery that was sort of created with this, with the architecture of this. So these are the stations under construction. The roof was made just using a steel structure. The walls were made using the compressor blocks. So you can see below, this was before it got finished. And one thing as well that's quite unique about this is that the earthen walls, especially raw earth, has a very excellent thermal inertia, which for the climate that we have here, which is generally hot and dry, works pretty well when you have thermal massing, when you have very compact typologies with thermal massing, because it makes the building less sensible to the variation that you can have, let's say, between day and night. Like typically in the desert, you could have a 20 degrees difference. It could be very hot in the day and then very cold at night because of the lack of humidity. So raw earth has great inertia, and on top of that, it also is a porous material, which helps to sort of regulate the humidity level. In this particular project, it was the internal walls are made using the cement blocks, the concrete masonry units, and I think this was done just out of to facilitate the coordination with services. I don't know if you can see on the inside here, the MEP contractors wait for the structural works to be done, and then they come and they literally dig through it to put all the cabling. Because with concrete, you can sort of plaster it, right? I mean, it's not good practice, but that's usually what is done. Of course, we can't do that with earth. So just as a precautionary measure, the double wall the cavity wall was opted for. And then the other advantage that it has is that you have this internal sort of air layer that is ventilated. So the wall, the holes that you see allow for air influx and then outflow of the air. Just making sure that it also contributes to the thermal regulation of these buildings. They still wanted to put AC units. I did not take pictures of it, even though they don't need it. But I don't think they were. Because, I mean, obviously the client was the state, and this technique not being very developed in the modern context, they were still very dubious and thought that they would still need air conditioning, which up till now, I don't know if they've had the need to switch on. So now I'm going to switch to our projects that were done, let's say, as a company. I mean, the first one is my first project that I've done as a lead designer. And the other project that we've done as well as a company and architectural practice. So this is a project that was started in 2018, and it's a family home project. So with this first image on our residential project, you will see some similarities when it comes to the materiality and this particular sort of texture that you see to the buildings, in which we have, and this is inspired by this is a tower in Saudi Arabia, in which you have these sort of stone elements. So it's built with mud, but in every sort of course, every so levels, you have stone elements that stick out. And what they do is that they provide shade onto the building, and it's sort of something that also helps to protect the walls in a way from insulation from the sun. So I'll show you a bit more in detail how that was used. It was first started on this project that I've done, and I think there's also part of me that subconsciously was very so impacted, I think, by my investigation into geology, into sedimentation as well, and just wanting to, I guess, yeah, again, very subconsciously recreate this texture. Which you can see then on this project. So this is a renovation of an existing concrete building that was built, that sort of belonged to my family, but was left unfinished. And I saw an opportunity to do an extension of this project in adding these earthen blocks. And it's really through this project that I learned about everything that I knew. I mean, not everything that I knew in terms of construction, but it was the first time that I was able to sort of experiment with the material, and the fact that we had already been working on the competition together. I met all these like wonderful architects, including Shiv, who had experience building in India. There was just this very natural transfer of knowledge, and I guess also with this project, just a willingness to experiment as well with earth and with Tifa, which I will show you a bit more. So this is the project that is featured at the RA. And just to show you a little bit what the plan looks like, the original house was just this L shape. You can see that the walls are about a bit thinner here. They're about 150 millimeters thick before rendering. And what I my main concern was economy, right, in a way. And I figured that by kind of adding only two earth volumes, and kind of infilling the in between with literally, I think I just infilled it with sand and put a slab. I mean, I had to sort of close it on the edges, but really having a very sort of light structure in the middle to create living spaces. And this is also very much inspired by the traditional compound typology, in which you have individual units that are organized around a central space. So that was my my inspiration for let's say the plan layout. And then with this addition, these two additions, which is one is being served as a kitchen, and the other one as an independent loft unit, I was also able to kind of bring out these earthen blocks and play a little bit with the materiality that I wanted to express. So this is the axonometric that is at the Royal Academy. I've just taken part of the graphic that is submitted. You have and with this, what I wanted to be able to express is the processes behind these materials that we use. So the two ones, one being the Tifa, that is usually taken in the north and is crushed in one process, is crushed, mixed with earth to make these Tifa panels. So these sort of square panels, or is also mixed with earth and then put into a mold in order to make these Tifa blocks as well. And then if you take a little bit more of a low cost, because with the Tifa panels, you still need to crush the Tifa to sort of make it into finer particles. If you take the much more low cost approach, in which is just taken from the river and then woven just by hand, generally by women, then you still have these huge panels that can serve serve as insulating panels. And then the other process is the process of making the compressed earth blocks that I've shown you. And these are actually, you can see the two the L that became two separate volumes with different heights, which I made on purpose because of the orientation. So on the southern edge, on this edge, you have the view onto the sea. So the point was to sort of bring up the buildings on the northern side to kind of leave the view onto the sea. And the story of this project is that it was being done the same time as the pavilion the Eco Pavilion that I showed you previously. And because that was priority, I knew I wanted to use the blocks, the insulating blocks for the roofs, except there were issues in production, so I had to adapt myself and use essentially what I had. So on all these different roofs, you have a different sort of materiality. In one, I had to use the concrete beam and blocks and then put the Tifa panels on top of it. On the other one, there were no square panels, so I just had to use the woven panels on top of it. I'll show you the picture. It's only on the last one here that I was able to actually use the beam and block using the Tifa blocks. And in the in-between spaces that were just infilled, you have these beams that are on top of it, there were wooden planks, and then on top of the wooden planks, the Tifa panels, and on top of it, just uh, uh, a sort of a small, what do you call it? A small, not slab really, like a 40 to 50 mil slab was put on top of it just to be able to put waterproofing. So back to the bricks, just to show you a little bit the process of the bricklaying and also of the colors. So the way that because again I wanted to be able to really experiment with the material, I asked for two different types of colors of bricks to be produced. So just playing a little bit with the dosage and using a different type of sand. So you have some of the bricks that were kind of this light pink, and the other one that look very much like the color, the natural color of laterite. So these are the two bricks that were made. And in the process, what usually happens is that the bricks have to be laid out. First of all, I have to draw the brick detailing, which I'll show you. They have to be laid out without any mortar. I go on site to make sure that it's laid out according to the plan. And then if there are any sort of discrepancies between the plan and what has been built, it can be sort of fixed. And then the workers dismantle it before building it correctly. And the other thing that's very important is to get especially the electrical wiring, because with the plumbing, it's preferable to not like have it inside the wall. But with electrical wiring, it has to be put in the middle of the joint. So that's also a very important part in terms of the coordination to make sure that we have the electrical wiring where we want exactly all the various appliances. So this is extremely, let's say, time consuming. You know, if you go back and remember what people in Casamance use, the way that they build just with the hand, this is very labor intensive, but it also gives the possibility to kind of express a very unique materiality that we can only get with these earth bricks. So the way that they're being done is horizontally, so just one layer after the next, and then whenever there's a plug that needs to be taken out, there's a sort of a reservation that is being left in order to then be able to put a socket. And generally, the walls here are load bearing. They're about 300 mil in thickness. So it's kind of like a double wall. They're load bearing. I think with this volume, we just needed to have an internal column, but that's because of a floor, an internal floor that we had. But on the perimeters, we don't use columns. So all these walls are 100% load bearing, and we use reinforced concrete to put for the foundations. As you can see here, the foundation wall, and also for the beams. So and that generally we rather have as ring beams. And in here, I don't know if you can see, but you have a concrete beam and you have this L-shaped steel cornice, which I'll come back to, was very important to me as in terms of detailing for this facade. This is what the bricklaying drawings look like. One thing that I also learned as soon as I moved here and through doing this project is that when you want to have a load-bearing wall with bricks, you have to be very meticulous about the way you lay them out and the joints, and avoid any type of vertical joints that you can have. And the bricks throughout the different layers have to be able to cross to create a very unified wall. So what you cannot do, for instance, and in my case, sorry, I had 3 different sizes of bricks, which is what gives it the materiality, with this middle course being the one that sticks out a little bit by about 50 millimeters, 40 to 50 millimeters, providing that shade that I showed you in the reference image. But what you cannot have on this third course is two parallel walls like this, because otherwise they will operate as two single walls. So through all the different layers and the alternating of the course, you're kind of creating this strength. You're kind of giving this strength. It's almost like weaving. You're almost like weaving the walls. So these were these took me a while. I remember spending about 2 weeks the first time, 2 weeks continuously doing these drawings, having to redo them whenever they wouldn't work, and then afterwards started really enjoying the modularity of these bricks that they sort of provide, and that in a way, if you understand it, even if we haven't done the drawings for like a simple wall, without this unique design, it would just be kind of very straightforward. There's a bit of a science to it, but after a while you get you quite get used to it. So that's what the drawings look like, and you have to sort of dimension it and sort of put color codes. So in black, for instance, are the bricks that are cut, and generally the reason also for doing these drawings is to minimize cutting on site. That's and you can see it, most of the bricks are just whole bricks, and only on a few places in some corners do we have to cut it. And we've then evolved to just make sure to use always modular lengths of the bricks to sort of avoid this cutting, but sometimes it's necessary and it's really not a problem. And the exercise, I had to do it completely in 3D, so not just in plans, because I also wanted to make sure that the facades were going to look exactly how I wanted them to look. And there's something quite unique with this volume because it's a double volume, but I didn't want to, and so obviously you have these ring beams. You have two sets of ring beams. One when you have the floor, so above the door is the lintel, and there's also an intermediate floor, and what at the roof level, and then you have a bit of a parapet. Just to contain the sort of the rainwater, and to have these vertical walls. And as you can see, the facade is completely continuous, which for me was a design choice. I remember having very lengthy arguments with my with the Indian architect, because he just felt that you should always express, you should have this honest expression of what the building, how the building is made. So just express the concrete ring beams. But yeah, I wanted something else. So I made sure to have a detailing, and that's why there was also the L-shaped steel cornice that acts as a lintel and was bolted to the concrete, to sort of be able to have all these bricks in the front of it. And I must say I was really happy with the general result, because I thought it really expressed the volumes, the verticality of the volume really well. And this is another facade. This was all done in 3D. I mean, I mostly work in Revit. So on the project, I usually know exactly the exact number of bricks that is needed. And that is something that helps a lot as well to order the bricks at the factory. We know we don't have to guesstimate. Or in my case, at least, I know the very exact number. I will give always a little bit of tolerance, because some break during transportation. But I just feel that in this case, it's completely controlled, with the architecture. And then, so, the in-between spaces. So this is one of the new units that were added, and there were these sort of concrete beams that were supposed to be to hold the roof of the in-between spaces. And even then, I didn't want. They are supported obviously on the concrete beam that rests on the earthen walls, but I didn't want it to be visible. So after it was built, after these beams were made, the infill of the bricks in between was done, and I was very adamant to have this type of result, rather than to have the kind of horizontal interruption. And this is what it looks like, the detailing. So you can see the concrete beam. Oops, sorry, my battery is running low. 1 second. Sorry. So that's how that detailing was made. So you have in this case it's a lintel that was made in concrete. So it's fit. The wall is about 300 mil. So in the inner layer you have 150 mil of this concrete beam, and then you have this cornice that was about about, let's say, 150 by 150 that is bolted to it. The engineer had to specify the spacing of the bolting, these little dots that you can see. And then on top of it was that after it was bolted, just a new layer of brick was put to kind of clad and cover this concrete lintel. And then this is the result. So you can still see a little bit this line. You can still see the cornice, but just overall, there are no interruption, let's say, to the facade rhythm and pattern. And this is what I was saying about the roof insulation. So these are the three techniques, various techniques that were used. And literally, this was just because of issues in production, really, and delays in production, because I didn't want to delay the site. So the one below is really what is intended to be. So you have these beams, and then the blocks are in earth and Tifa. And in the top picture, it was the traditional one that we used, and the Tifa panels put on top to insulate, and on top of it, then a sort of waterproofing was put. And then on the other one, one of the earthen blocks, it was the woven Tifa panels that were used. And again, just waterproofing and this small, I can't forget, it's not like a type of very thin concrete slab was put in order to have the waterproofing. It was put with a slope, sorry, and then the waterproofing was put on top of it. So this then becomes also another experimental building that the Ministry of Environment has put on its program to take measurements and see how all the various roofing perform. And I'm really excited again to have a bit of input to know which one is going to perform the best. This is an intermediate project that we've done. It's not very extensive, but it's a house. I think this is one of the first one that we got commissioned to do, with for private client. It's again articulated around two main volumes. The client was very adamant about not wanting a flat roof because he felt like flat roofs give waterproofing issues. I mean, I tried to explain to him that it's bad waterproofing details that sort of give leaks. But anyways, he really wanted to have this sort of slope roof and a big sort of metallic structure, and to have this sort of covered veranda. We were south facing, so to have this very extensive shaded space. And this is what this is just an extract of the model that I do this. So this is just for the masonry, for the earthen, for the compressed earth bricks. Just what I was saying about the extent. I mean, we've had to adjust a little bit the configuration and add these parapets, but in general, all the various type of bricks, I modeled them, and the colors that you see indicate the sizing of brick. And I always print these in 2D, so in plan, in elevations, but also in 3D, in order to help to just leave them on site, in order to help the workers kind of see, and literally count and know where to put each and every type of bricks that is needed. So that's what this color coding looks like. And this is the project under construction. So we have on the main facade this small detail that the client sort of requested. We like to be playful and also express these textures, just because it's an opportunity that this materiality gives us with all the different type of earthen techniques. Let's say with gram earth, you have all these different layers, right? Because that's how it's being built. With cob as well, even though it's built by hand, you can read these layers. But with the bricks, it's like Legos, they're modules. So we really make it a conscious effort to express that in order to also sort of showcase the uniqueness of this particular material, especially in a context in which it's not so common to use that. And it's usually very well received by clients, especially residential clients, who always want a very unique product. And in our case, come to us only because they want buildings that are they want bioclimatic homes, and they want them made with earth. Another thing that we've done as well here is to experiment with having recess and to have a maximum of built-in furniture as well. So in this case, we're going to end up adding some wooden slabs in order to use it as a bookshelf. And the last project that we've done, and that is still ongoing, which is our biggest one to date, is the one that is on the site that I showed you earlier. This is the project, and in its context, I should put the picture of the context now. This was already last year when it was still under construction. I mean, it still is, but we really was just starting to we're getting only to the second level there, and as you can see, it's about 1, 2, 3, 4, let's say almost a 5-story home. It's on a very small plot of land. It's 150 square meters. The client wanted to also have a swimming pool, so we had to really, and without having to exceed the 70% of land, we had to essentially grow vertically, but we still managed to have quite a few setbacks in order to not interfere with the right of light of the neighbors. So that's the final facade. You can kind of see how is kind of it was being built, and compared to what the final product is supposed to be like. And these are some of updated. This is from it's actually the same facade. That was earlier this year, still on the construction. How high it's gone. With this project, it's a bit of a mixed structure because whenever we use earth load-bearing walls, they end up increasing the more the sort of the weight of the stories above is. So let's say if a wall is carrying an increased weight, it will thicken, it will become thicker. And because the plot was so small, when we initially did the calculation, we were going to end up with walls that were about 600 mil thick, which happens a lot in traditional urban construction, but in an urban context, we just couldn't afford to lose that much space. So we opted to have a mixed structure in which we use columns, but the columns work in with the walls. So the walls are load bearing as well, and the columns will sort of designed by the structural engineer to be like supports in a way. And then these are the mock-ups of the different of the bricklaying process, because the client has seen my previous project and she wanted to have the exact same one. So we slightly changed it. Instead of having 3 different sizes, we only had 2, which works better in terms of shading the wall. And we also wanted to try and play with color, but she didn't want it. So we just kept the same red lateritic color for the facade and the texture. And so this is just looking at the section of the building. One thing that we were able to test in this particular project is to also have load-bearing floors. So instead of having the beam and block floors that we've had, that we also use whenever we have a flat floor, we opted to have this sort of vaults, which are structurally load-bearing as well, and to also have them as ceiling finishes. So on these 2 particular spaces, you can see, especially in the bedrooms, that we've put that we've opted for this type of upper floors, and this is what they look like. So the vaults, I mean, the curvature is not very accentuated in order not to increase the flow buildup, because if they were a little bit more pronounced, we will have to increase the height and the flow buildup. This in turn we understood that it kind of gives a lot more pressure on the tangents on these beams. So on future project, we sort of opting to have a little bit more to increase the curvature of the vault and to have like more barrel vaults, bigger barrel vaults rather than these small ones, which are about, let's say, 700 in width. No, 800. Sorry, 800 in width. And yes, sorry, this is the picture from the back of what it looks like. And I think at this particular time you can just see the type of materiality, the type of texture that our brick detailing sort of gives on this southern facade. And yes, this is the last project, like William mentioned at the beginning. So we were invited to showcase some work at the Royal Academy of Arts. The theme of the architecture room this year, it was curated as well by David Adjei, and the theme of the room was climate and geography. So I thought it would be good to be able to show not only some of the work that is being done, show the processes that are behind this materiality that is being used, but also kind of bring a sample of the brick. So that was the most challenging part, is transporting this brick and getting the certification to make sure that it's safe, getting it framed on the kitchen table in London, and also just being able to really have it in the space, because I felt that it was important to be able to, if not touch it, at least see it and understand a little bit, even though people can't carry it, but if you do, it's very, very dense, to be able to see the type of experimentation that we're doing locally with the materials that we have. And yeah, so this was the final result, and this was me a few weeks back at the opening of the show, and I was really pleased. It's, I think, quite a milestone to achieve, to be able to do, to show work at the Royal Academy, but also now share it with you at my old University of London. So thank you very much, everybody.
Thank you so much. That was great, and great to see the projects. Do we have any questions in the room or online even? Yeah, we have a question now. I'm going to pass you the microphone.
Hi, it was amazing. It was really encouraging, and it was really inspirational. I kind of have a question. So initially, when you experimented, what was kind of like the testing process, or like how long did it take for you to kind of convert that from like a concept to like a building? Like what was kind of that process like?
When experimenting on the first project.
Yeah, like with the brick itself, like with the materiality, because you're using like different, like how kind what like what was kind of the thinking that like that it's kind of strong enough to kind of convert into the structure, like what kind of made you confident, like what was that process like?
So in the whole process, and I think one thing that has been great as well about the collective, so I mean, I've only shown the architects, but there's quite a few engineers that we work with, and Dudu himself is a trained structural engineer. So from the very beginning, I think I've always sort of understood the like I said, the bricklaying, not just to express a certain materiality, but to be for load bearing project. And the structure was designed, and the span of the walls, the span, sorry, of the slabs were calculated, taking into consideration the load bearing building. I must say, the setback, for instance, that I wanted to do of about like 40 mil on the outside, when I first spoke to the engineer about it, she freaked out. She's a really dear friend. And she was explaining to me that everything needs to be centered on the wall, because otherwise this thing is going to collapse. And then what we sort of ended up, the conclusion was to understand that the 300 mil was not the sort of effective thickness of the wall. It kind of worked with a slimmer thickness of about 200 mil. So I figured, if in section we have, a continuous 200 mil, and there's like a minimum of eccentricity, it would still work. So that was, I think, a lot of the conversations were mostly at the design stage with the engineers, to make sure that they were confident, and they will calculate this thing to make sure that it was going to stand. And then the rest was really based on, or it was on site. I mean, I would go to the factory. You saw the first test that I did with the colors, get the different sizes, and then just play with the bricks really on site to see what it would give. But from at least a design perspective, I just needed to, it's the engineers that made sure they told me that this was going to stand. And as far as the bricks go, we're very lucky to have had the seniority that Doudou has, because he's been in Senegal for 12 years now. He's had the company for 12 years, and he's gone through the certification process. So we found out, for instance, that there's a national standard that regulates the compressed earth blocks, and he's wants to have the certifications, and he's worked with other labs before. So which is why, like I say, it works easy in this urban context to do this type of houses using his bricks. But anywhere else in Senegal, I don't think it would make sense to necessarily use this technology, and we could rely more on more empirical and traditional techniques like cob and adobe.
Oh, I see.
I hope that
Thank you so much. Yeah, it was very clear. Thank you so much.
Thank you.
Hello, thank you for your presentation. It was super nice to hear. I just wanted to ask you a quick one. Why do you think, after knowing that vernacular architecture has been so successful and all of the techniques have been successful for so many generations and such a collective memory process, why do you think modern architecture has abandoned it? And how would you recommend to like approach this? Because I don't know how vernacular architecture is in Senegal, but I bet there's a lot of modern architecture trying to like push away all these old techniques. So like, how is it to work against modern globalization, if you want to call it?
Yes, yes. That's a really good question. It's one that I guess, every single day we kind of working towards dispelling the myth that earth is a precarious material, right? Because and this happens in every conversation. I could have this conversation waiting, like, buying bread, with somebody who asks me that I do. And whenever I say, I'm an architect and I build with mud, the first reaction that people have is to tell me that mud isn't a sturdy material. There's sort of this idea that there's a precarity to it, that is confined to the past, that is confined to rurality, and not really one that is deserving to be made in to be used in the city and in a modern setting. What I understood through my research projects and processes is that we've come to this type of reflection because of a different type of let's say, of politics that have happened throughout the year. There was a law in 1966 that said that you couldn't build with materials of recuperation or precarious material, and it listed earth in it. The cement factories and cement companies have a lot of political leverage. And I think, and that we have three, within, again, 2 hours of Dakar, we have three cement factories. And I understood that they're multinational companies. They're very powerful. They have a lot of political support. And I think throughout the ages, probably in our history here, since the colonial times and independence, there's just been this kind of a narrative that was, I think, created in order to sell really concrete. I don't know. There's not really money in using using a material that you find in your backyard, like the people do in Casamance. So that's my reading of it. That it was sort of marketed as a more sturdy material, and it sort of populated people's like the imaginaries of modernity and of the city. So in that sense, it's kind of a very sort of political and ideological kind of reflection. But the same way that the people that sort of work with us are people that want to build differently, are people that have a sort of sustainable consciousness. And many people just didn't think that it was possible to still do it. Many, including my own parents, had projects since the 90s, not knowing who would be able to build an earth building for them here in Senegal. So I think there's a lot of people are just pleasantly surprised to see that, it is possible. Even though we are a minority, a few people that, have trained and are learning and are showcasing things that can be done. And like I say, I think it's just we show by example, and the more that we show that it's possible and is also beautiful, and the more people would adhere to it. And we do modern buildings that have the shape and the typologies of the rest of that car building. You know, we don't here need to put thatch roofing and things like that. So it's slowly becoming acceptable. And this particular project in Gore is helping us a lot because, like I say, it's a 5-story home, and just to have it in such an urban setting is really dispelling a lot of myths, and people are just slowly welcoming it as an alternative.
Yeah, thanks so much. That was a excellent question and great answer. So Raluca, I think, has a question.
Hi, yes, that was a really great presentation. Thank you so much. Do you think this material can be used in different kind of climate, maybe more rainy one, even in the UK or some other countries? Do you think that could be an option in the future?
Yes, just because it's been an option in the past. I forget the data, but there was a sort of survey that was done showing that I think in most of the rural world in this planet, the buildings, most of the buildings are built with earth, and like I say, in the planet that ranges continents and climatic zones. The impluvium houses that I showed you earlier are from the south of Senegal, where it's a bit more of a tropical environment, and it rains a lot. The consideration, like I said, are of the choice of material and how you build has to be guided by the climate. You know, if it rains and we build with adobe, for instance, we need to have overhangs to protect the walls. So the architecture in a way has to adapt to the climate and the material and how we sort of use it. But in terms of the UK, and well, at least, you know, UK and France, I've seen a recent kind of a project, but that used mostly, I think, ram earth, much more than compressed earth blocks. Why that is, I don't particularly know. I don't know if it's not, you know, it doesn't seem sophisticated enough. And I guess fire bricks are also something that is traditionally very much used in the UK. So the advantage of and also being in a different climate, I think there's a goal to insulate buildings a lot more, to for instance, keep the heat in. And here, particularly, we don't have it. We don't have, other than the flat roofs, a particular concern for insulation, because just with enough ventilation, we're able to have optimal thermal performances in the building. But in practice, in theory at least, I think it could work as a material as well.
Oh, thanks very much. No, I think you're absolutely right. And there are many examples of earth buildings in this country, but they are generally rammed earth, even things hundreds of years old, and earth and cob and stuff. But I think not compressed earth bricks, because unfortunately we just don't have the sun to dry them out. I mean, I think it's probably is as simple as that.
It's a good point.
So look, I just had one very quick question. But what are you sticking this stuff together with? What's the mortar? Is it earth and a bit of cement, or is it lime, or is it?
Yeah, so it's earth with a bit of cement, but otherwise with lime. There's a current project to be able to produce lime that also to do is implicated in it, because even though it's marginal, I think we just want to be done with cement. I mean, lime also takes, you know, a certain level of energy to produce, but it's kind of less polluting, and there's a, you know, a controlled type of access to shells that we have here. So yes, it's a laterite, sand, and cement, or lime, whichever we find as a because lime right now is just a bit more expensive than cement, because it's imported. Sorry, but yeah, that's what the mortar is made of.
Great. Well, look, thanks.
And have to be able to put pavilions, which we're working on. If we just use a sort of sand and laterite or clay content, it means that we can lay the brick and then take them out easier. So that's another thing that we all use, interlocking bricks and things of the sort. So we're also working on that for a future project.
Well, look, thanks so much again. It was really terrific. So that was great that you could join. I'm sorry about the technical problems, but thank you, Teo and Asif, for sorting it out. And great to see you again. So next time in London, just
Yes.
stop by and come see the students and see the students work. All right, but really inspiring to see the work. So thanks again. That's terrific. Thank you.
Thank you all for listening. We appreciate it.
Thank you, Sam. Oh, and Nzinga, I should tell you how to log out, which I've forgotten how to.
Yes.
How do you do that? You go to. I've forgotten how to do this.
Just close the browser. Just close.
I think just if you
Just close the browser.
I just close it. Okay, that's easy enough. Thank you, everyone. Have a good evening. Bye.
Bye-bye.
Bye.
Oh, there we go.